Hello, good morning. My name is Emmanuel Kwansa. I'll be your moderator for today's meteorological seminar series. And today we are privileged to have with us Mr. Brahma Mohammed, a meteorologist at the Ghana Meteorological Agency, the headquarters in Accra, Ghana. He's going to present on variability of the minor season rainfall over southern Ghana between 1981 to 2018. At this juncture, Mr. Brahma, if you are ready, please, you may start. Thank you.
Thank you very much. Good morning, everyone, and then welcome. Today, my name is Mohammed Brahma. I'm in the Ghana Meteorological Agency, and I'm giving a presentation on the variability of the minor season over southern Ghana from 1981 to 2018. We look at the outline of our presentation. We are going to talk about the introduction, beginning with the introduction. We look at the objective of this work, and we look at our research questions, the study area. We'll talk about the data and methods that we applied for this work. And then we are also going to talk about the results that we got at the end of the work. We'll conclude the work and then show the reference where you can get further information from. So we see that the variability in the rainfall events has resulted in extreme events like devastating floods. We have droughts and floods in West Africa. So in Ghana alone, we have about 3.81 million people who have been affected by flood. We have about 298 people from 1968 to 2011 who have been killed by the incidents of flood. We've also lost a lot of properties to flood and then extreme weather events. So in Ghana, we have major studies that have been carried out on a seasonal and annual scales to study variability of the rainfall season. So we have a special feature that we have seen is that most of this work, they do study the temporal and then the spatial variations of rainfall. For instance, we have this work which was written by Baidu et al. In 2017. It analyzes trends over Ghana, and then it found out that there's a decreasing trend of seasonal rainfall amounts over the agroecological zones of Ghana. That work studied between 1901 and then 2010. We also have a very interesting work by Ousu and Wailing, who reported that rainfall during the September, October, November season, which is the minor season, and the beginning of the April, May, June season, which is the major season, encountered a reduction between 1951 and 2000. Another interesting work that we also see over the Ghanaian jurisdiction in terms of the rainfall climatology is the work by Nyatuami et al., which was written in 2014. This work also talks about the rainfall variability over the Volta region of Ghana, and then it shows an oscillatory rainfall trends for different months in the year. So we can see that extreme rainfall events usually occur in the major season, that is the April, May, June, July season, where we see that heavy rainfall usually occur. We have so much floods happening in the major cities of Ghana. And then we have the general public, and then the press in Ghana are raising concerns of what is actually happening to the minor season. It looks like rains are increasing. There are so much floods. For instance, in 2019, we have a flood which swept across Cape Coast, which is very unusual in October. So people are talking what is actually happening. So it's therefore warrants the need for further studies to understand the recent trends of rainfall in the minor season. So we look at where we are going to do our analysis. That's the study area. So we have southern Ghana. So southern Ghana, we have between latitude 5 degree north to latitude 8 degree north. So this area, we have 17 synoptic stations over these stations. We have Adan, Accra, Tema, Soton, Takrady, Axim, Akusi, Koforidua, Akimoda, Sehubekwai, Ho, Abetifi, Kumasi, Sunyani, Winchi, and Kitikrachi. So these areas have 2 rainfall seasons. So we say that southern Ghana has bimodal rainfall regime. That is the major and the minor season. And then, as I said earlier, the major season starts in April and end in July. After that, we will have the August, which is the little dry season, followed by the minor season, which continues from September to November, before the main dry season comes in December. So this map shows the stations over southern Ghana that we use for this study. So for looking at the bimodal rainfall season nature, we look at the stations. The first chart is the stations over the coast, and then the second is the stations over the middle and the transition zone. So we can see clearly the bimodal rainfall pattern showing in the peak of the major season is June. So it starts from April. From January, you see that the rainfall begins to rise small. We are still in the dry season, coming to the February, March, then April, the rain begins proper. Then June, we see the peak for the major season. We get another dry season in August. That's the little dry season, as we are going to meet the minor season. So after the little dry season in August, we get our minor season, which also peaks in October. This is not so different as compared to the stations over the middle sector and then the transition zone, where we have bimodal rainfall season. Although the stations over the coast have more of higher rainfall amounts as compared to, for the major season as compared to the minor season. But when you check the middle sector, the peaks are not so much different, even though we have more stations having higher rainfall amounts in the June, April, May, June, July season. So our analysis is going to focus more on the September, October, November season. So these are as we showed on the graph, these are the behavior of rainfall in the country. So in January, we see some few rain cases coming in, about we see a maximum about 20 or 30 millimeters. February, the rainfall the rain starts coming in, but the season have not begun proper. March, we start getting rains, but April, May, June, we see very high amount of rain, up to 300 millimeters in June. Then we come to July, August, we are going to the dry season, the little dry season. Then our second season begins in September, continue to October. November, we see that we are getting dry, we are getting the dry season is coming. So we see that in the north, we start getting very low amount of rainfall. Then as the rain is coming south, and then finally December, we see that we are going to get a rainfall behavior which mimics that of January in the dry season. So that is how, but our analysis are going to focus on the September, October, November season. Yes, as it has been shown by the diagram. So we look at the objective of this work. So the main objective of this work is to provide a quantifiable understanding and enough scientific evidence regarding variability in the minor seasons over southern Ghana. So we seek to answer the following questions. One, what are the current trends of rainfall in the minor season over southern Ghana? And the second question we seek to answer is that the southern Ghana experience extraordinary rainfall in the minor season in recent times. So in recent times, we choose between 2014 to 2018. Did we have any extraordinary rainfall amount? And then what is the current trends? Are rainfall increasing as people are saying? The floods that are happening in October, November, September, October, November season, is it because we are having so much extraordinary rain, or what is the current? Are the rainfall increasing? So that is what we seek to achieve. So we look at the methods that we applied. First, we talk about our data. We use the rainfall observations, that's the daily rainfall observation from 1981 to 2018. And we did the analysis to check for missing data. And we found out that the missing data is less than 2%. So less than 2% were found in each of the stations over the study period. So we also did homogeneity tests and normality tests, and we found out that our data was approximately normally distributed, and then the data was homogeneous, so we can go on with our analysis. So for this analysis, we grouped the stations into 4 sectors based on the geographical locations. As our coastal sector, we divided into 2. We have our eastern coast. We have the eastern coast. Sorry for drawing you back. I'm going back to the map. So we have our eastern coast, which goes to Accra, Tema, Ada. Then the western coast goes to the western part of the coastal sector, Southern, Takoradi, Axim. Then we have our middle sector, which captures up to latitude 7 degrees north. That's from all the way to Akimoda to Kumasi area. Then we look at the transition zone. The transition zone have some features. It's between the north and then the southern half. So it also have its unique climatic features. So we consider from Sunyani, Kitekrachi, Winchi as our transition zone. So back to the methods. We look at after looking at the data, we look at our rainfall amount, frequency of occurrence of rain, and extreme precipitation indices. So we first calculate rainfall totals and the frequency of occurrence. For the frequency of occurrence, we take any rain event that occurs in a day. So from any rain event that is measurable by our rain gauge, which is 0.1 millimeters. Even though when you read our paper, we also have special rain days that were done at 1 millimeters. So we do the descriptive statistical, we do descriptive statistics. So we compute descriptive statistical parameters for each station. And then we computed the ETSCI, that's the World Meteorological Organization's expert team on sector-specific rainfall indices. We take the heavy precipitation days, which is R10, that's rainfall greater than or equal to 10 millimeters. We look at extremely heavy precipitation days, which is R20, that is rainfall greater or equal to 20 millimeters. And then we look at very wet days, which is rainfall greater than the 95th percentiles of the, so that is for our classification, that's our groupings. So after that, the next thing we did was to find trends. We find trends and standardized anomaly indices. So first we find time series, we plot time series to just get the general linear trends that the precipitation and rainfall frequency shows. And after that, we used the Mann-Kendall trend analysis to find trends of rainfall amount, rainfall frequency, and then the ETSI indices that we computed. So the Mann-Kendall trend test, also it retains several parameters that give us a good idea of what is actually happening, whether there's a significant trend or the trends are not significant. So we look at the results, and when we did the time series plots of rainfall over southern Ghana, we see that almost all the stations are showing positive slopes of rainfall amount, which gives an indication that at least there's an increasing rainfall amount from 1981 to 2018. So when you look at the first station, that's Axim. So per our grouping, the stations on the first line are the Western Coast station. So Axim having positive slope, Takoradi, Salt Pond, they are all having positive slopes indicating an increasing trend. And then we do also for the stations over the Eastern Coast, which are all showing positive slopes, an indication of increasing trend. So we go to the frequency of occurrence. So, sorry, we are still on the rainfall. We are still on the rainfall trends, that's the rainfall amount. We also see these are stations for the middle sector. So over the middle sector stations. So the middle sector generally shows more of positive slopes. So we have the first station here is Ho over the Volta region, showing increasing with positive slopes, even though the value of the slopes are not very high, that they are not very, the magnitudes are not so big. So we look at the transition zone, and then they are also showing positive slopes. Okay, so after they're showing the positive slopes, that is when we do the Mann-Kendall trend analysis to explain whether these slopes, these trends are significant, even though the rains are increasing, but are they significant? That is what we are going to look at in the coming slides. But before then, let's look at the descriptive statistics of the minor season. That's the total rainfall of the September, October, November season. We see that first we look at the coefficient of aeration. With the coefficient of aeration, we look at how the rains are varying, the variability. So we see that along the coast, especially the eastern coast, there's higher variation. So between 60 and 70%, or let me say 50 to 65% variability, which is very high. But the rest of the country, the variability is more moderate, that's greater than 20%, and then less than 50%. So let me say moderate. And then we also, to check whether there are outliers in our data set, we look at the kurtosis. The kurtosis also give us whether we have the data, we have some outliers. And then the range we used was between -7 and 7. That's our threshold. So we can see that most of the data sets we used as the rainfall data are within the -7 and 7. So from -1 to 6, which shows that there are no significant outliers in our data set. And then with the skewness also tell us whether the data is symmetrical or is skewed to the right or skewed to the left. But as we see that most of the stations are slightly skewed to the right, that is an indication that the rains increased close to the earliest days that we use. That's from which we are considering 1981 to 2018. So we are having a slight positive skew, even though it's not that higher. So we can say that they are skewed to the right. So they are skewed close to our 2018 year. So it's not much of a surprise that the regression analysis are showing increasing trends. So we have the standard deviation of the minor season. It also shows how far the data sets are dispersed from the mean. And then we see that the variation between 70 and then 130 millimeters. So there's a lot of variation. And then we also look at the mean rainfall. That we see that stations over the middle sector, the transition zone, have higher rainfall amount as compared to that of the coastal sector, especially the eastern coast. So we also see for the minimum rainfall is also showing similar behavior as the mean rainfall, with the middle sector having higher rainfall amounts as compared to the coastal sector, especially the eastern coast. This is not so much different from the maximum rainfall amount. So we also do another descriptive statistics for the rainfall frequency. And then with that too, we also see very good variability in the rain days, that's the frequency. So we have about to 50% over the eastern coast. And then over the middle sector, we have more moderate variability for the middle sector and the transition zone. The kurtosis also give us, except one station, I think that's Winchi area, that's where we have kurtosis about 7, which gives an indication that there might be an outlier in that area. Apart from that, there are no significant outliers. And then with the skewness too, we can see that the data seems to be, the skewness is more symmetrical because we have more of negatives, and then that's from -1.8 to 2, which is more of a bit symmetrical, even though it's not, there's skewness, but it's good. So with the standard deviation too, we have between 2 to 10 rainy days deviation from the mean. And then the mean rainfall days too, we also have the coastal sector having the least number of rainy day, the rainfall frequency as compared to the middle sector. And then also with the minimum and the maximum also showing a similar pattern. So after showing that we have the variability in rainfall, and then the plots telling us that there are increasing trends. We want to know whether these trends are significant or they are not significant. Whether they increase, they can be an increase, but are they significant? So we use a Mankendal trend test at a confidence level of 95%. So it means that the confidence that we are using to say that a rainfall is either increasing or not increasing is 95%, which is very good. So we look at when we run the Mankendal package, we use the Python package known as PyMankendal. We run and then give us the trend, the H is the alternative hypothesis, which if it's true, it means there's a trend. If it's false, it means there's no trend. And then we have our p-value, and our p-value, if it's less than 0.05, there's a trend. If it's greater than 0.05, there's no trend. We have our Z, we have our Kendall, the standard test statistic, the variance, and then the sense slope. The sense slopes also, positive sense slope indicates at least an increasing trend. So when you look at the sense slope values for all the stations we considered, you can see that we have positive values. But at that significant level, at that confidence level of 95%, we check whether the trends are significant or not significant. If it's not significant, we say no trend. If it's significant, we say increasing or decreasing. So we see that Akimoda and Kumasi are the only two stations out of the 17 rainfall stations we used are having increasing trends of rainfall amount, Kumasi and Akimoda. The rest are all having no significant trends of rainfall amount. So we look at the frequency of rainfall. With the frequency of rainfall occurrence, we can see that about 8 stations are having increasing trends of rainfall frequency. So we have Adan, Tema, Axim, Koforidua, Akimoda, Sefibakwai, Kumasi, and Ketikrachi. So these are 8 out of the 17 stations, which is nearly half of the stations we studied. And a station, at least there's a station in each of the sectors, the East Coast, the West Coast, the Middle Sector, and the transition zone that are having increasing trends of rainfall frequency. So we look at the R10, which is the rainfall, the number of days with rainfall greater than or equal to 10 millimeters or heavy precipitation days. And we see that Akimoda is the only station that is having increasing trend of heavy precipitation days. So this is clearly showed here with the alternative hypothesis as true. We have other parameters also confirming. So we have talked about the frequency of occurrence, and we look at the R20, which is the extremely heavy precipitation days. Rainfall greater or equal to 20 millimeters. So we see that we have 4 stations out of the 17 stations, and these stations are all in the middle sector and are in the forest areas. So Abetifi have increasing trend. Akimoda, we have Sefibakwai and Kumasi. So we can see that Kumasi and Akimoda are doing very good in terms of increasing trend. And we look at the very wet days, that is R95P, rainfall greater than the 95th percentile of rainfall. That's the number of days with rainfall greater than the 95th percentile. That one, across all stations, we see that there's no trend. So, which is confirmed by the slope, 0.000 throughout. And then all the p-values are greater than 0.05 with our force as the alternative hypothesis. So after looking at the rainfall trends, we also look at the variability in terms of recent times. So we look at 2014 to 2018 to check what is so different. So if we do the spatial analysis, we see that 2015 have lots of rainfall less than the zero mark, that is negative, a lot of negative anomalies, rainfall less than the mean in 2015. But when you look at 2018, we can see a lot of positive anomalies over the middle sector, and then also a lot of positive anomalies over the middle sector in 2016. But the rest for 2014 and then 2017, especially the western coast, have near normal rainfall, except the eastern side that we are having some kind of below normal rainfall. So we can also check them by station by station, and see that for Ada, we can see that it's all 2016, only 2016 is having rain greater than the mean. The rest are all below normal rainfall over. Our benchmark was between 1981 to 2010. That was our benchmark mean, and we compared it with the current years. So we also look at Tema. For Tema, apart from the 2014, it was above normal. We see that it drops again and increases again in the 2017 to 2018. So we see that Tema from 2017 to 2018, the rainfall was above normal. In Accra, all the years are having above normal rainfall. That's even though the trends are not increasing in Accra, but we see that in Accra, all the 5 years are having rainfall above normal. So it means that between 2014 and 2018, there was an increase in rainfall in Accra, even though the trends are statistically not significant at the confidence level of 95%. We also look at the western coast over South Pond, Takrady, and Axim, and then that place too, we see that there's kind of increasing and then decreasing, a similar pattern. So we have a decrease that's below normal, above normal, below normal, above normal. So kind of, let me say, sinusoidal over the western coast. And then over that's the middle sector, we also see lots of positive anomalies over the middle sector. We look at Kumasi from 2016 to 2018, higher than normal rainfall. Koforidua from 2016 to 2018. We look at Sefibekwe all throughout, positive anomalies. Abetifi too, apart from 2015, the rest are all having positive anomalies, indicating there has been an increase. And over the Volta region, Akachi, Akuse, these stations are also showing, let me say, some of the stations are above normal, some of the years are above normal, some of the years are below normal over these two stations. As other study by Nyatuami et al. Talked about the oscillatory behavior of rainfall over the east, the Volta region. And then except for Ho, they are having below normal rainfall for the recent years. But when you look at Akemoda have a very good performance of rainfall for the recent years. So there's no doubt we are having increasing in all the indices that we studied, showing that Akemoda is very unique. Apart from Akemoda, Kumasi is the other unique station with increasing rainfall trends. So we look at one Other interesting thing we have to see is that the transition zone are having lots of rainfall below normal. The transition zone from Kitekrachi, Sunyani, and then Winchi, they are having lots of rainfall below normal, as was shown in the graph, sorry, the spatial plot from 2015. You can see lots of, let me say, not dryness, but below normal. We have below normal in 2017, below normal in 2018. Okay, so to summarize, we used a trend analysis of the minor season using the Mann-Kendall test at a significant level of 95%. And we found out that 15 out of 17 stations have no significant trends in total rainfall amount. So rainfall amount in general, the increase is not significant or simply no trend. We have 8 stations showing significant increase in trend in rainfall frequency. Well, for the rainfall frequency, we can say that at least there's an interesting trend because 8 out of the 17 stations, close to half of the stations are having significant trends according to the Mann-Kendall tests. And then we see that when we looked at the descriptive statistics, we see that there is high variability, moderate to high variability of rainfall amount and frequency using the descriptive statistics. And then the minor season for 2015 was relatively below normal. And we look at the middle sector, shows highest number of stations was above normal rainfall. And then the transition zone, as we saw, is also showing a relatively dryness or below normal rainfall. So to continue our summary, we see that the minor season in 2015, okay, as I mentioned, it stands out as extremely dry, and then the minor season in 2016 and 2018 are wet comparatively. And then the middle sector, no, I think this is a repetition. Okay, so to conclude, we see that rainfall amount show moderate to extremely high variability. That's between 25.3% to 70.8% variability. That's using the coefficient of variation. And then the degree of variability in rainfall frequency is moderate to high, between 14.0 to 48.8%. So we can say that rainfall, there's a variability in rainfall amount and its frequency. And we show that the middle sector, as I said earlier, they have higher amounts of rainfall amounts and even the frequency of occurrence. And then the result of skewness and ketosis also show that the data is fairly symmetrical, and we don't have serious outliers. Then we see that the eastern coast have lower rainfall amounts and its corresponding frequency. The stations over the eastern coast, Accra, Tema, Ada, have rainfall that is less than that of the middle sector. And then this is the climatological behavior and the vegetative cover and other factors might be the cause. And then we look at many stations over the many of the station studies are positive slopes, which portrays at least increasing trend. That's per the simple regression analysis. But when you use the Mann-Kendall test, we see that even though when you just plot it, it should show you an increasing trend, but the trends are only significant for Kumasi and Akimodan for rainfall, and then about half of the stations are significant for rainfall frequency. And then the middle sector, we have 4 stations located over the middle sector have significant trends of R20, which is heavy precipitation, extremely heavy precipitation days. So it means that the middle sector is a sector that we have to look out for, because probably there's a greening of vegetation or other parameters that we have to look out for the middle sector. And then these are all the 17 stations studied have no significant trends of extreme wet days. That's R95P. We don't have any significant trend. And the magnitude of the trends that is the slopes are all zero for the very wet days. So we recommend that future studies should look at modeling the minor season rainfall and being able to predict and giving us the long-term behavior. So this one will also, so our work can be a document for further studies to stand on, and then do higher studies that will model the whole minor season and even the major season, and then make predictions, long-term predictions for the future. So we also have this, the results presented here is a paper which has been published in the Advances in Meteorology Journal of Hindawi Publishers. So you can check it out and then read more. And if you have further questions, you can channel it to us. So I'll say thank you very much. And then if you have further questions, we will be glad to share our views. If you also have input that you think will enrich the understanding of the seasons in Ghana, you can also bring it out. Thank you very much.
Well, thank you very much, Mr. Brahma. And I'm sure your listeners have lots of questions for you. So I wouldn't waste time. So at this moment, if anybody has a question, suggestions, or some comments, you are ready, we are ready. You can raise it. If you raise your hand, fine. If you can also type. Yeah, so we want questions and also comments. Okay, so I can see here, Bright, if Bright, you can ask your question. Then
okay, thank you. Good morning. Great presentation. I really enjoyed it. So I realized that there was well, I'm currently on vacation, specifically at Amejope, right? And the elevation is around 700 meters at the minimum. In the general vicinity, it's around maybe 400. And Ho is used as I guess, a proxy for this general area. And Ho is elevated at just 150. And so being here, past few days, I've realized that there's a microclimate of its own up here. And I think that using, for instance, Ho as a proxy for maybe the southern part of the Volta region just doesn't work. And so I think my question is more for the metro department, more so than, Dr. And I guess my question is there any plan to kind of put up stations in places that are a little higher? Because this place is almost like Abetifi, right? But we have, numbers for Abetifi. And so I guess my question to the doctor is that, would you, for instance, say that there will be similar patterns for a place like Amejope and Abetifi? And can you, make projections based on that, or you think that there is definitely a need to implement something different here to capture numbers from this side? Great presentation, really enjoyed it. Thank you.
All right, so Mr. Brahma, do you want to continue, or you take some more questions before?
Okay, I would like to answer.
Okay, go ahead, please.
Yes, thank you very much for this wonderful question. And then you see that we are dealing with temporal and spatial scales. So when you are dealing with space, the more stations you have, the more accurate you can be confident. And then the station Ho representing the southern part of Volta region is this work, we look at the stations that have good number of rainfall that we can be confident about. Even though Ghana Meteorological Agency, we have several stations, including agro-meteorological stations, hydrometeorological stations, and we have automatic weather stations. These stations might not be able to give us a long-term data set for our analysis. That is why we went on to use HO, and HO has been in existence for a long time. So it can give us a very good representation of that area. So to your question and your input, is very good if we have more stations to use, especially when you do the spatial plots and we are doing an interpolation and the data are very close, you can get more of accurate representation than using very few stations. Because as you said, maybe in Accra, the behavior of the area in maybe the southern part of Accra will even be different from that of somebody who is living in maybe Dodoa or Medina. You understand? So it's very important that we have more stations to help us to get an accurate or a very defined or refined, information about the area. And for the predictions, as we recommended further studies to also look at modeling the area and also giving us predictions for a long term. And the Ghana Meteorological Agency have also been giving out seasonal and then weather forecast, daily weather forecast, seasonal forecast, and others that you can also look out for concerning the predictions over the area, especially those areas that we didn't look at it very critically here. I hope I've answered your question.
All right, thank you, Mr. Brima. We now go to Jacob. Jacob, please go ahead. And
hello, good morning, Mr. Brima. Good morning, everyone. Thank you very much for that presentation. I have some few comments that maybe you might want to look at in your next research endeavors, and then I have some questions as well. So you see the Markandale trend test actually doesn't show some sort of any significant trend for major parts of the stations. Maybe you could consider looking at the trend analysis for decadal, time steps, because for as maybe you did for the latter part of the study, looking at some few years, you could do the decadal trend for you to actually ascertain whether we have a general decrease within the 10-year periods. That could also lead to some bit of forecasting for the future model simulations, that maybe for the past 10 years we are expecting rainfall or extreme rainfall to reduce or to increase. So this is just a suggestion. And then for the extreme indices, I think I have had the opportunity to work on some extreme indices, and things came to mind as to the already defined indices. Some of them may not actually represent our area very well. For example, if you look at what they are defining as extremely heavy precipitation, rainfall greater than 20 millimeters in some part of our regions, that might be even the least we will record for a year or for the rainy season. So in future studies, maybe you might want to redefine your own extreme cases, and then that will give a more befitting analysis for our area.
Okay.
And then for the Candle analysis, you showed a lot of variables from the analysis, but you are just speaking about mostly the P and then the slope. So if you don't want, because I felt you put the values, the variables there without talking about them.
Okay.
And I think you can actually do the whole comparison or the analysis or the trend from just maybe the P and then the slope, or if you want to explain the other variables, so that's fine. Then my question has to do with why did you have to do regression before you went ahead to do the candle analysis? Because the regression I see looks more of just univariate regression, which is, if maybe you are regressing against another data or a different data, that would have been, I'm not too sure why you had to do that analysis before you went ahead to do the candle trend test.
Yeah.
Okay, thank you very much. These are my few comments and then question.
Okay. Thank you very much for the input. And if I'm to start with the question, we did the regression just to show that that's for the layman's view, that is what you can see. If you just plot the rainfall amount, this is what you're going to get. Okay. And when we did the Mann-Kendall test, even though the Mann-Kendall test gives us a greater, data output, like the trend slope, we can see that the simple regression is not talking about whether it's significant or not significant. So we just showed the regression analysis for anyone who may want to look at it from the layman's perspective. And then for the regression analysis to talk about the detailed with confidence. And that is why the Mann-Kendall test have confidence attached to it. You understand? And then your input.
Sorry to cut in. Maybe we might not want to call it a regression, but maybe a simple time series. Because a regression suggests something different. And again, if you should make a plot with the Mann-Kendall trend test, you will get something similar to what you have already plotted for the regression. But maybe you can just call it, because I was confused with the regression and the Mann-Kendall. But from your explanation, it sounds more of a simple time series.
A simple time series, yes. A simple time series plot. Yeah,
okay,
exactly.
Right. Thank you very much.
You're welcome, Jacob.
All right, so thank you very much. We now go to Dr. Ayi. Dr. Ayi, if you are ready, please kindly ask your question.
All right, sure. Thank you very much. Yes, I mean, great presentation, Mohammed. On the light and let me say, it was very colorful and flowery, your slides. So that's
thank
good.
You.
Yeah, and then just a few comments, I think, in line with what Jacob said, and then also what the first the first person also asked. Now, if you can take us to your slide 16, I just want to ask something because I'm a bit skeptic on this. So, talking about the magnitude of the slope being small, right? But then, at least if we look at this one, for instance, there's a magnitude of about 1 millimeter per year. All right. So if it's a 30-year period, on average, you are getting about 30 millimeter increase. Now, if that's the case, I mean, that is still very huge a difference. And at least from the operational perspective, that's so huge a difference. And I believe you would also want to communicate that clearly to your listeners, or I mean the various people on board, so that at least we get it clearer. Okay. And that's where sometimes there might be, I think that's where Jacob was also trying to hit on, because then it becomes difficult to marry these slopes we are seeing, which are sort of showing increases with the Mann-Kendall. All right. So ideally we want to stick to one. And then another point would be why the R squared, I mean, your coefficient of determination, because I mean, the rainfall is not necessarily dependent on the time. So you wouldn't want to show that. So I mean, those are just some key things to look out for. And then if you could quickly maybe take me to your slide 25, I believe. Yes, I mean, this was very interesting to see, at least looking at Accra, for instance. When you go back, you would see that the trends you were getting were not so significant, but to have, about 4 years consistently, almost above, 1.5, greater than the normal, that is something to look out for. That could also be informing on the fact that within more current years, we can't just say that floods in the region are just, human induced, but then definitely there could be some climate contribution. Now, there's a need to do some sort of attribution to really clearly justify this, right? Now, the other aspect too is you would want to, for instance, take in Accra and then say Hibekwai. I don't know if you have plans to look at any dynamical or local terrain specific reasons for these observations. I don't know if you would want to, you have plans to look at something like that, because I believe it will be very interesting.
Yeah, it looks very interesting. Accra, even Akimodan is a very station that is showing more of increasing trend throughout. And when you look at this slide 25, you can see Akimodan is showing all positive, and it's kind of still increasing from 2014 to 2018, which is very, very good. So it's a very interesting, observation that we can do more detailed analysis about those stations, Accra, Akimodan, Kumasi, or Seshibekwai.
Yeah, I think that'll be very interesting to see. At least there's more like a baseline, a framework. So if you would want to, you can also build more into the dynamical and then the localized terrain specific reasons. And I'm sure that would be very interesting for almost every socioeconomic indicator. And the final thing is, I don't know if I didn't get it, but clearly you didn't tell us the impact of your work on the socioeconomic indicators. If there are specific stuff you'd want to share with us, and that'll be all. Thank you. And also a very colorful presentation.
Okay, thank you very much. Yes, you talked about, Jeff, we talked about the socioeconomic impact. That's basically, we look at the extreme climate events. These are the floods, which are affecting most places, especially Accra and Kumasi. And recently, Cape Coast are also been added to the picture. And we can say that in recent years with this analysis, we can see that in the recent years, rainfall are actually been increased. But if we are to use on the statistics or the mathematical perspective, the increase is not too significant, but at least there has been an increase, and even in recent years, rains are keeping on the rise, which are greater than the normal, that's the normal rainfall. Therefore, we should still look out for activities involving extreme events like heavy rains, floods, and then other extreme activities. Yeah, that's what I'll say.
So can I just clarify something, Mohammed?
Yeah.
So you see, the moment you're talking about the trends, that you were looking at that with respect to a 30-year period.
37-year period.
Yes, like about 37-year period. That's good.
Yeah.
Now, but when you come here, you are looking at just the 5-year window, right?
Yeah.
So these are actually observations within the 5-year window relative to that long period. Okay, so if you have your trend is like the magnitude over the whole period, but this is now how this compares with sort of the normal or the trends. And this will then give more weight to what Jacob was saying about trying to probably go into maybe sub-decadal or more decadal analysis. Yes.
Okay.
And then I forgot to even ask, also, if you see all these observations that we are seeing, these increases in the minor season rainfall, for instance, in Accra, Seshibekwai, and then also more progressively in Akimodan. Somebody would also want to know how these are sort of going to affect the patterns. Are they going to have any huge impact on the rainfall seasonality, the rainfall patterns, and then?
Okay.
Yeah, thank you.
Yeah, thank you. You are welcome.
All right, thank you very much, Otai. So now I have a question. Somebody wants to know. Okay, so Jacob, you asked a question that could you share light on the interest in minor season. Is that correct, Jacob?
Yes, I think in relation to why maybe the socioeconomic benefits, why are you looking at minor seasons? Maybe if we get that, we can get why. I mean, we can get some of the benefits to looking at, as Jeff pointed out, maybe the impact on the general seasonality of rainfall in these particular areas.
Okay, thank you.
Okay, thank you, Jacob. The reason we are interested in the minor season is the recent concerns by the public on recurrent rains. People are asking, is it October that we are having so much rains like this? Is it September that we are having so much rain? This is the climate, is climate change. And people are talking climate change. Do you understand? So this is the main reason. And then we are having so much floods. Like 2018, there was a flood in Cape Coast and Accra. We are having so much floods, which if you look at the floods history, it used not to be like that. I think there's this work done by I think I've forgotten the author's name, but when you look at it, it states all the floods and then the dates that the flood came. And you can see that it wasn't the norm to get floods in September, October, November, December. Sorry, September, October, November season. So getting more floods in the October, and that's and heavy rains, and people talking, why are we having so much rains? That is why we got interest in tackling the minor season alone, because basically it's the major season that shows that kind of heavy rains. And then, yes, we know that June, July is in Ghana. The layperson knows that June, July is the heavy rainy season of Ghana. But when it comes to September, October, November, basically people are talking. So we want to get a scientific evidence to back it that is the rains extraordinary? Have rains even increased? That is what we indicated in our research questions. What are the current trends of rainfall? Did Southern Ghana experience any rain in the extraordinary rainfall? Yes, so that is the main reason why we looked only in the minor season. Jacob?
All right, thank you very much, Mr. Brahma.
Okay.
Please, do we have some more questions? Yes, I have seen one more. Okay, it was the old one by Jacob. Please, listeners, do we still have some more questions? If we don't have more questions, then Mr. Brahma, we will say thank you very much for giving us some time out of the busy schedule to.
Doc, just a quick one, if I could ask.
Oh, okay.
Okay, so I just want to be sure how this is going to translate from publication or just the PowerPoint into more operational and practical stuff. I'm hoping it wouldn't end on the shelf. That's I don't know if Mohammed understands.
Yeah. I understand. And then this is kind of the norm that used to be there. There's the people publish and leave them in the desk, and then the operational level 2, there will be different thing altogether. So with this PowerPoint or the paper coming out, I think it will inform all of us who have participated in this seminar. And then if possible, we can give some briefing to the operational people to also, communicate when they hear the public talking about climate change. They can also talk about, oh, why are you getting so much rain in October? The October panels with us, we can at least, communicate it to them that at least we have done some 1 or 2 studies and then we saw that this is what is actually happening. Yeah.
Brahma, make it possible, not if possible. Make it possible.
Possible.
All right. So
hello.
raise your hand.
Sorry. Last one.
Yeah.
Please Brahma, would you then from this study say that, I mean, if you want to answer another question from the public, that why is it raining so much in minor season? Would we say it is why are we having floods? Would we say it is because of the climate or because of our activities as humans? I just want to know from this study if we can answer that question. If not, maybe
okay.
What's next?
Okay, from this study, actually, as the people are talking so much, are the rainfall increasing? Are the rainfall increasing? Statistically, it's not actually increasing so much. But we can say that in the few years, we are having rains above the normal. That is, even though we are having rains above the long-term mean, it might be little, probably climate variability and not climate, maybe not, it's more like serious change, but it could be that in the next 5 to 7 years, it can also decrease again. So with regards to your question, I think that we can say that rainfall actually is not changing too much. So probably or perhaps human-induced activities are the main causes of flood, because the flood started for a long period of time, and then it has been so much floods. So we can say that human-induced activities are the major cause, even though we are having some, because we can also take some years, as Jacob said, decadal. We can also check, and then in some other place you can see that maybe there may be a decrease or maybe normal. So for climatologically and statistically, we can say that the climate, the rainfall the change is not so significant, and we can put our energy into the human-induced activities that is causing so much flooding. Yeah.
Right. So thank you, Brahma. Somebody asked a question sorry, there's a question from Mensa Atakra, and it reads like this. Good morning. Please, I'm a broadcaster. I'll be happy if one day you can organize Zoom lecture for the media on how to present weather report and terminologies in the report. Thank you.
Okay. Thank you very much. Thank you very much. I think I will have to communicate this message to the officials for them to take in the necessary, so that you follow the necessary protocols. That if you want to organize training for the media, you have to come to GMET and then see those in charge, and then they will organize training they will talk in the terms, they will have to go with you, and then you can get your training done. It's as simple. So just come to GMET, the client service unit, or I can get you the email address of the client service unit of GMET. You write to them, then we'll attend to you as quick as possible.
All right. So another question from Kara. So sorry, I missed most part of the presentation. Mr. Brahma summarize. Can Mr. Brahma summarize the presentation for me? So Brahma, can you summarize the presentation, please?
Okay, thank you very much. To summarize the presentation, we are looking at the trends of rainfall over the minor season, which starts from September, October, and then ends in November. So we are looking at the trends of rainfall. Are the rainfall increasing? Are we getting an extraordinary rainfall amount? And then we're also looking at extreme indices. Are the heavy rainfall increasing? Are extremely heavy rainfall increasing, or they are not increasing? So we used a method known as the Mankendal analysis. So we use it to test whether there is an increase or there's no increase. And our Mankendal test showed us that rainfall amounts are generally not increasing. But we looked at some few years between 2014 and 2018, and we selected these years and then checked the behavior of rainfall. And we saw that from 2014 to 2018, some stations, like Accra, Akimoda, Kumasi, Sefi Bekwai are having increasing in rainfall, which are, above the long-term average. And then we see that stations over the transition zone, that is stations from Wenchi, Kitikrachi, and Sunyani, are having rainfall that are below normal rainfall between 2014 and 2018. So our let me say our one sentence summary is that rainfall for the past 37 years have not encountered any significant change. Thank you.
All right, thank you, Mr. Brahma. Please, do we have more questions? Okay, I don't think we have some more questions. Okay, so we have one more. Emma, you have raised your hand. Please kindly ask your question.
All right, then. Thank you very much for your presentation this morning. Yes, so I think there's just some key input I want to make in terms also relation to the economic impacts that have been made with regards to this. Yeah, few station subjects being used from the synoptic station, as Brahma mentioned, that we'll be able to get a long-term data. So all the other input that have been made for us to go, maybe looking at other time scales, those have been considered, and we look at that as well to see how best we can be able to understand more microclimates for other areas as well. So in terms of the economic, Brahma spoke more to the disaster side, but also for the agri sector too, it's also a great information to them, because the farmers also want to know how the rainfall variabilities are behaving, so that they can be able to know the types of crops that can be cultivated. And then also in terms of the, this information could also help the agri extension officers to know that in terms, as you are saying, like we are not seeing so much increase in terms of the amount, how they can still adapt in terms of the variability we are seeing in advising farmers on how to really plan during the minor season that will not run at a loss, or even investors who will be able to invest into these farmers to be able to make some impact there. Also for the energy sector, we know that we also depend on rainfall for most of our power generation. So this information, VRA also contact us as well. The BPAP authority, they are also in touch with us for information. So this is also to help them also understand how the rainfall pattern is varying from the minor season, how we can improve our production within those seasons as well. That's why we are looking at this as well. Also, this can also be used for the health sector as well. I think this can also inform for further studies to see how this rainfall variability, because also affect malaria like this. It can be something we can trace to rainfall as well, or diarrhea or cholera. Some of these things can also be further studied. So I think in terms of some of these economic impacts, this is some extra information that I wanted to add that also informed in these studies as well. But the other input that have been made, we duly noted that, and we will look at that. And I also like to use this platform to encourage also, most of us do, when we are doing research or projects, we install stations and we are not in touch with the Met institution. I would like to encourage that when we are planting some of these stations, let us be aware that we can all see how we can share some of this information. At the end of the day, it goes a long way to help, especially the forecaster on the decks, to know how to see if they have these values, or they know how these seasons are varying, especially with respect to your microclimate, can help inform the forecast, the day-to-day forecast that they issue over your area, as well as in terms of our seasonal forecast that we also issue. With our lady who mentioned about having a training session for the media house or something like that, your input is well noted. Currently, some training are already going on, especially for some people in the north, farmers in the north, and some over the southern sector. So for the media, some was done over the north. Your input is well noted. I'll ask if you could leave your contact and your details, and we'll see how we can get in touch to organize something like this for you. Yeah, thank you.
Okay, thank you very much. So now we go to Kwesi Green. Please, Kwesi, if you are ready.
Yeah, thank you very much. Yeah, thank you very much, moderator. Brahma, thank you for your presentation. I think this has been mentioned already, but be careful how we interpret some of these results. In the sense that these are in the realms of non-significance. Because if you test your trend, because the lady who just spoke mentioned that we, DAM, and all those people are in touch with this information. So we as climate scientists, we have to sound a word of caution. The fact that we've made the trends does not mean they are significant. You see, there are other factors in play. So if your trend is not significant, then you have to look for answers that will make the story a whole story. So please, let's be careful on how we communicate this results, because we have to be the right people to interpret them. Thank you.
Okay, thank you very much.
Thank you, Green. Yeah, do we have some more questions, please? We still have some few minutes for some more questions. And if not, then we say thank you, Mr. Brahma, for your presentation. I think we have been educated, and I would like to also thank everyone that was able to join us today. We hope to see you in our, we want to see you at our next presentation, and have a wonderful weekend, which is starting tomorrow. I hope Ghana wins today to begin our weekend very well. All right, so all the best and thanks for coming. Bye-bye.
Okay, thank you very much.
Bye.
Bye.